Welcome back, everybody, for the last session of the day, one of the best sessions of the day. I'm here with Jimmy Bogard, who has inflicted AutoMapper on the world. I'm kidding. Actually, I've used AutoMapper and love it. But Jimmy is here it's obligatory when talking to Jimmy to give him crap about AutoMapper. Jimmy's here to talk to us about domain-driven refactoring. Can't wait to hear it. Jimmy.
All right, thanks for having me. I did bring my mask just in case, but I don't think I'll need it today, so we'll just put that away. So thanks for coming, everyone. Good day, evening, morning, wherever y'all are across the world here. So yes, my name is Jimmy Bogard. You can find me on Twitter at @jbogard. And these slides and all of the code for this will be found on my GitHub at github.com/jbogard. There's a presentations repository there where all my stuff is. And I blog about this topic and a lot of other things at my blog at jimmybogard.com. So this talk is a fun one I like to give because it's very code oriented, and it really deals with a lot of stuff that I do on a kind of a daily basis, which is really dealing with kind of like existing code bases and doing a lot of refactoring with them to try to make them more domain-driven design-ish. But before we get into the code, I want to kind of level set first about what is domain-driven design. And from the Blue Book, they define it as an architectural design strategy in which we selectively distill, organize, and abstract the body of knowledge from the users to the software. And kind of the keywords there are going to be to distill, organize, and abstract. Now, we're not trying to model exactly the real world because, well, nothing can model the real world except for the real world. But we're trying to take like a subset of that and distill it down and make it more meaningful to what the business needs. And so one of the things that comes out of domain-driven design is, well, I have to write software that represents the model of the real world. And so as part of it, we eventually will get to a domain model. And domain model actually predates domain-driven design. It came before that, and domain-driven design kind of just built on top of it. But the idea of a domain model is an object model of the domain that incorporates both behavior and data. Not just behavior. If we just had behavior, it would just be functions. And not just data. If we just had data, that would be a database or just DTOs. So the key there is to have both data and behavior and my object model that represents the domain. And we want to go beyond just kind of the nouns and verbs and really represents the overall interactions and behaviors of that domain. But a lot of the code that I deal with isn't kind of a greenfield starting from scratch. We're going to make the most perfect domain model. It's usually dealing with a lot of brownfield code bases that have been around for years, even decades sometimes. So the code that you have may not be the perfect domain model that you want. So how do I take that code that I have and get it into a domain model that's actually does represent that domain? And so the key here is red, green, refactor. That's kind of the test-driven design mantra, right? Like you write a failing test, you write a passing test, and then you do that step that everyone skips, which is the refactor step. But most legacy code I work with, they don't have the first two steps. It's just like, we wish we had tests and wouldn't that be great? But we could still do that last step of refactoring. Now, when I want to refactor a code base, we need to have sort of a kind of a guideline or kind of a way forward of how we want to refactor. Even the techniques we want to build on top of, we want to have like kind of a shared language with our team to say, this is how we want to refactor the code base. And so for this, we actually have a lot of existing literature out there that describes how to refactor a code base. And the three greatest books that I've worked with on how to refactor a code base, first of all, is kind of an interestingly named book to Working Effectively with Legacy Code. But this book really describes how do I safely and effectively refactor existing code that doesn't necessarily have any tests associated with it. And the other two that I find that are really great, of course, are Martin Fowler's book, which is a catalog of refactoring. It's called Refactoring. There's a second edition out now that's based in JavaScript, whatever. But it's really just kind of a catalog of refactorings, but not necessarily a way forward. It says, here's a code smell, and here's how you can refactor, or here's some possible refactorings based on these existing code smells. Another one that's kind of lesser known out there is the Refactoring to Patterns book. So I think a lot of folks are familiar with the design patterns, the Gang of Four book. But some new developers see those design patterns as kind of like a checklist or just kind of things I need to incorporate all of these into my code base, and then maybe it'll be good at the end. But the Refactoring the Patterns book I really like because it's similar to the refactoring book. It starts with design smells or code smells to say, okay, these are the kinds of things and frictions you're encountering with your code base. Here's how design patterns can be applied to that code base to improve the overall readability or maintainability of that code base. So what I'd like to do is take an existing set of code and then use these techniques to refactor it towards a domain model. So these books don't really talk about refactoring towards any specific direction, but domain-driven refactoring is really about taking, using these techniques to refactor towards a direction of building into a domain model. So let's look at the current state of our application and system. So the current application I'm working with, a code base actually does have some kind of information or data model. And this is what we have now. And so this domain is a domain for loyalty reward systems, which are kind of ubiquitous these days. So you go into a store and they say, would you like to join our rewards program? And in exchange for your email or phone number, then you will get like coupons and rewards as part of that. And what they get is like all your personal information and all of your purchase history, which they feed into some kind of like machine learning, something other, and you get emails that are very targeted for you. And so in this domain model, we have data models that do actually represent the ubiquitous language of the business. So someone that wants to join the rewards program is a member of that program. So we have a member, not a person or just a user or something like that. It's a member, and that term is something that the business actually uses as well. Now, a member will have offers assigned to them, but there's some special characteristics about that offer. We can't just assign anyone any kind of offer. Like, it's not like the cashier is just writing something on a piece of paper on a slip and saying, here's a special offer for you, sir. Well, they're going to have like different kinds of offers. And so each offer will have an offer type. And that offer type is kind of the metadata about individual offers. So behind the scenes, there's some kind of administrator that's building up the different offer types to say, well, we'll have it start on this day and end at this day, or it's going to be valid for this amount of time. This is the name of it. And then when I assign it to a specific member, that's that offer table in the middle or the offer object in the middle. So if I look at each of these objects, each of these types, the name of the type, the name of the class, and the name of the data members, the properties, will line up to the names of things and the names of information that the business uses. So that's already a really good step towards a good ubiquitous language and a good domain model, is making sure the names line up to the concepts that the business uses. I see a lot of places that don't even get that far, that they have like, well, the business calls it member, but they're really just a person. And the developers have to do this translation in their head of like, well, when they say person, the business means member. When the business says member, we have to translate into person. So the business can look at this class diagram and they would probably agree with everything they see here, even down to the relationships of things. So looking at the arrows between these different boxes, those represent the relationships between these objects. So a member has a collection of assigned offers. And we don't just call it offers. The nature of the relationship is an assignment. So we say we assign an offer to a member. And so the names of those relationships represents the nature of the nature of the arrows there. So we can look at this and say, yes, the business agrees about all this, but you notice there's something missing here. I only have properties on these types. There aren't any methods. So there's no behavior associated with these objects. Now, in any system that does things, right, there's going to be behavior, but where is the behavior in this system? Well, in a lot of legacy systems I work with, behavior could be all over the place. Typically, it's in places like a controller or a code behind, or the page click, or the button click events. Or we could have like pulled things together related to a specific entity or a specific class and say, oh, now we have a member service or a member manager or a member, well, any kind of fill in the blank here of some like generic name of a service class that is where all that behavior exists. So there is behavior somewhere in the system, but it's not in the domain model, it's somewhere else. Either services, controllers, or whatever it might be. So what I like to do is take one of these service classes that represents just kind of the very boring procedural behavior of the system and refactor it towards a domain model. All right, so let me switch over to Visual Studio 2022. So we'll see how this goes in the new Visual Studio, now with more bits. Okay, so in my solution here, I've got my services, which is really where all the behavior is, and my domain model. And the domain model here doesn't have any behavior associated with it. There's no methods there. And so what that often is called is an anemic domain model, because there is no behavior. It just has the data, but no actual behavior. The behavior here, though, is in this class. And this class represents the operation to, in this case, called assign offer handler. So it's all the logic needed to assign an offer to an individual member. So let's look and see what's going on here. So first of all, we see that we are using dependency injection. So yay, I guess. And we can see that in the constructor, we take a DB context. So that's an entity framework thing. So we're talking to a database here. And we're also taking an HTTP client, which means we're having to talk to some kind of web service or API to be able to do something else. All right, so in this class, there's one method that has all the stuff in it. And right now, this is just very kind of boring procedural code that is just everything associated with assigning an offer to a member. So the first part of the method is, well, it's actually very common with a lot of operations I see in my systems. The very first thing I typically have to do is load data out of the database to be able to act upon it. And so that's what those first two lines of code are. I'm assigning an offer to a member. So I first need to load the member out of the database. And then I need to load the offer type out of the database. And so the two pieces of information coming in are the member ID and the offer type ID. So I'm assigning an offer of this type to this member. All right, so we can see that this method must have gotten long because the previous developer was nice enough to offer code comments to tell us, like, these are the things that are happening in this method. So the first thing we see, it says, okay, it's calculating the offer value. Hopefully that is still accurate because code comments never lie, right? And this is the logic to assign or calculate an offer value. And it looks like we can see here that this is the part that's going to be talking to an external web service. So it uses the HTTP client to call some web service to calculate the offer value, passing in the member email and the offer type. And then the response coming back is just a number. That is, here's the value for that member. So it looks like there's some kind of personalization here that maybe different members have different values of the offer. And it looks like they're using the email as a way to kind of key off how they would calculate individualized offer values for individual members. What's going on behind the scenes? I don't know. It's probably in the details of the web service. Maybe they're saying, well, you're a very loyal member. You spend a lot of money with us, so we're going to give you a better offer for whatever reason. In any case, that's the first part here, is to calculate the offer value. The next set of logic here is to calculate the expiration date. And it looks like there's a couple different strategies of how they can calculate the expiration date based on this switch statement. So the switch statement goes off of the expiration type of the offer type. And based on how this offer expires is how we'll calculate the end date. And it looks like there's two different ways we can calculate the expiration date. There's based on the assignment or based on a fixed date. So assignment expiration date says, okay, what we'll do is it's based on the day that you assign the offer. And so what we'll do is we'll add a number of days to today and say that is how long this offer is going to be valid for. The other kind is a fixed date that says, based on, instead of going off of today, and then it's really just a total number of days. So if the offer was given on the first of the day and it's offered for 15 days, then it's always a fixed end date as well. And so it calculates the expiration date based on adding off the big end date as opposed to today. And so this is how it calculates expiration dates. And finally is the assigning of the offer to a member. So once I have the amount of the offer, the expiration date, I can build up this offer object and then assign it to the member here. And it looks like there's an extra calculation. So I have a number of active offers I increment. And that is for some calculation purposes. So if I log in, I see the number of active offers. That's probably something that just makes it simpler for us to show information on the screen. We don't have to do a join to get that data. It's just like pre-calculated, and there we go. Now, looking at this code, I would say it's not terrible. It doesn't quite fit on one screen, but it's not completely terrible. It is very procedural though. So it's just like, here's all the code associated to do this operation in just one block, and that's it. And in fact, this is really how I tell my developers to start with any of their code that they're adding. Is just make it the dumbest thing that could possibly work, and then do that refactor step to say, where should this logic actually belong? Now, the first thing I typically do when I see a bunch of set of code here is I extract individual methods for each of the main level of operations that are happening here. And that's actually known as the compose method refactoring. So instead of extracting one method for one piece and leaving the rest alone, we extract methods for the similar conceptual level of this operation. And so if everything's at the same conceptual level, then it can kind of give it's kind of like chapters or story, chapters or sections in a book. It tells us this is the main things that are happening. If I want to dig into the details, then I can go into that method. So let's first extract methods. And by the way, I'm using ReSharper. I'm most comfortable with that refactoring tool. Most of the things I show you today can be used by Visual Studio, like the vanilla version. There's some things that can't, and I'll point those out as I go. So let's go ahead and extract a method. ReSharper is going to ask us, what should I name this method? And I'll probably just name it. Let's see, what was that code comment? Calculate offer value. So let's just name it the exact same thing. Calculate offer value. And I can rearrange the members or the parameters here, cancellation token, probably last, because that's not the most important thing. Next. And there we go. Now, one of the reasons I like to do this refactoring is because it tells me exactly what this block of code needs to work. Sometimes if a block of code gets really long, it can be hard to understand, like, what are all the things this block of code is using? And by extracting out into method, I could see like, oh, that block of code had the inputs of this, this, and this, and the output was that. And then inside of that method, I could see exactly what was necessary to be able to do that work. Okay, let's do the next one. Calculate expiration date. I highlight the code, extract method, give it a good name like calculate expiration date. And there we go. So that's interesting. It takes exactly one parameter in, the offer type, and has one value out. The other thing that's interesting about this method is I noticed that it's static and the other one is not, which means that all of the inputs to this method, or all the information and objects it works on, are all passed in via the parameters, and nothing's being passed in somewhere else. Now, in some legacy code bases really like static, so that may not be the case. Like it could be using objects somewhere else, but I do know at least for this instance, the instance of this class, it's not using anything else besides the parameters being passed in. The final one here is going to be assigning an offer. So let's go ahead and extract a method for that. Assign offer, and that takes the member, the offer type, the value, and the date expiring. Next. And there we go. At this point, I could probably remove those code comments because there's not a lot of value to say calculate offer value, calculate offer value, calculate expiration date, calculate like, okay, so at this point, the code comments aren't adding anything of value, so let's go ahead and delete those. So for a lot of my code that I write, I tend to actually stop right here because I feel like at this point, I've broken all the long method into individual smaller methods that describe what each of those different things are doing. And so at this point, I can very well tell exactly what the pieces are doing. However, this talk is not just refactoring, this is about domain-driven refactoring. So let's go a step further. What I like to do now is look at each one of these methods, look at the logic that it's doing inside of there, and then decide where should that logic belong in a domain-driven world. So first, let's look at the calculate offer value method. So in order for me to determine like where should this logic belong, I have a few choices of where it could go. First, I could look at the individual parameters being passed in and say, should the logic inside of here belong in that object? And to understand that, what I'll do is to see what is this logic doing inside of here, and is it mainly dealing with this individual parameter? So I can look at the usages of this, and I see that, well, it really is just only grabbing the email off of that, and that's it. So that's not terribly exciting. So that's not doing a whole lot. The behavior is just passing in a parameter, but the result of it is really encapsulated behind that web service. So it'd be, it wouldn't make a lot of sense for me to push all this behavior into that member object. What about an offer type? Well, again, it's just this one specific place. That's not very exciting, so let's just leave that alone. So if this logic doesn't belong in the member object or the offer type object, then maybe it's just a different object altogether. So in order to do that, I'll need to do a few additional refactorings to take this method and to put it somewhere else. Now, I could just like copy and paste it, make a new class and like just place it over here, but we're going to make this in safe small increments. So the first thing we're going to do is going to extract a class based on this one method. So I'll refactor it to say extract class. And it's going to have some red things that are like, okay, you need to fix these things. So I'm going to say, first, I have to name what the class should be. And right now, the name of the method is calculate offer value. So what I often do is just flip that around and say, this is the offer value calculator, to turn that verb into a noun. I also have a red piece here that says, hey, you gotta deal with this thing. And the reason I have to deal with that thing is this method is using a, let's see, where is it? Here it is using a private field. And so if I move this method into a different class, I have to do something with that private field. So what I'll do is I'll say, let's go ahead and extract this into a field over here. So it'll make a new field on the right to be able to do that. And the final piece is this method was private. I have to do something with that. I need to make that method public so that when I move it to a different class, it can actually call that method. All right, so let's go ahead and go next. Okay, so we now have extracted out an offer value calculator. It is just instantiated inside of the constructor, but it passes in that dependency of the HTTP clients. We can also see that it actually removed the HTTP client completely out of this class and moved it over here to this offer value calculator. So now it's being passed in as a parameter. The logic, though, is exactly the same as was before, but of course now it has a public method as opposed to a private method. Now, this is a kind of a weird name. I've got an offer value calculator, and the method is called calculate offer value. That is a little redundant. So maybe we just rename this method and call it calculate. There we go. So now we have down here offer value calculator that calculate, passing in all that other junk. Now, this in the domain-driven design world would be known as a domain service, because it's a service that is dealing with the domain. But if I were to try to unit test this handler class, I would have a problem because this thing underneath the covers uses a real HTTP client. So what we'll often do is extract an interface for this offer value calculator or these like domain services to provide a seam to be able to stub out the behavior in a test. So let's do that. I'm going to refactor this and say extract interface. And we're going to call it, well, I offer value calculator because that sounds pretty good. And of course, we want the calculate method to be part of it. So now I have an interface called I offer value calculator. And then this class implements that interface. Now, I don't like implementations of interfaces that have the exact same name of that interface minus the I. So let's call this something that actually represents the implementation details of this class. So this is a web service offer value calculator because it calls to some other web service. And there we go. So now it's a web service offer value calculator, and now I have this lovely interface here that represents some service that can calculate the value of an offer based on those parameters being passed in. However, my class itself is still not using that. So what I'd like to do is convert this into an actual injected interface here. So the first thing I'm going to do is on here, I'm going to refactor this to say, use base type where possible. So right now, the field there is of the concrete type, but if I ask for sharper, can use the base type where possible. So instead of using the concrete type, use some base type available for you. So if I do that, well, system.object, that's probably not the right one. And so let's go ahead and use the interface we created. And so by doing that, it'll say, okay, I'm going to, if there are any problems using the interface, it would ask me to do something, but there were no problems. I was able to change that. So down here, it is able to still use the interface one of that instead. Now, the final piece I need to do is it's newing up this object directly inside the constructor. So what I'll do is I will say, I want to introduce a parameter for this whole thing that's been newed up here. So I'll say, go ahead and introduce parameter, and tells me, oh, wait a second. Now that you introduce parameter, you can safely remove this. And I'm going to rename this to be the offer value calculator as a parameter name. So I'm using dependency injection, and it's telling me there are no usages of the constructor, so the value of the new parameter will be lost. That's okay. We'll fix that with our DI configuration. Let's go ahead and next. And now, actually, there we go. I offer value calculator is being passed in as that parameter. So the DI configuration, we can fix that over here. Over on configure, this is, in this case, I just got like a ASP.NET Core kind of application. I can say services.add HTTP clients, which is the way to have these strongly typed wrappers for calling web services that will automatically pass in the HTTP clients for us. So this is the I offer value calculator. And the concrete type is the web service offer value calculator. And then inside of there, I would give it the actual the web service URL, things like that. But that's outside the scope of this. So with that in place, my handler now takes in this domain service that is the offer value calculator. And so I've now safely extracted that logic that is calling to external services outside of this method, outside of this object, and encapsulated into that other object, the offer value calculator. All right, well, let's keep going. So the next one we have is the calculate expiration date. So let's go into this method. Okay, so we're gonna do the same thing we did before. We see a lot of logic here. We see it's static, so it's not calling out to anything else. And then its only input is this offer type object. So if I look here, the usages of this, I can see, oh, look at this. It's doing a lot with that offer type object. So that being the only parameter being passed in, this makes a great case or great example of something that says, okay, this is having an object being passed in and doing a lot with that other object. Perhaps this behavior is better suited to that other object altogether. So instead of me moving this method to some other class, I'm actually going to push this method into the offer type object. I can do that here. Now, there are some ways to do this. I can say, go ahead and move this to another type and then do a bunch of stuff from there. But there's actually a great shortcut here in ReSharper called make method non-static. And the make method non-static will say, in order to make it non-static, you need to make it into an instance method, and we'll give you the choices of the parameters on which to make that method non-static for. So make this method non-static. I will choose the instance parameter and click next, and it just disappeared altogether. And so now it says, instead of calling a method here, it actually says offer type that calculate expiration dates. And here is the place where it actually calculates that expiration date. There's some other things going on here. It's like ReSharper's telling me, oh, I can convert this to a switch expression. Oh, that's much better. Can I, okay, this seems kind of pointless where I have a date expiring that just gets returned immediately. So can I inline that variable altogether? Okay, that looks pretty good so far. And the final thing is, I just have one single expression here. So can I just make this an expression body method? And there we go. So now my calculate expiration date is completely encapsulated into now just a single expression that has been pushed down into my offer type object. All right, the next thing, I've got assign offer. So this is a kind of funny thing though. If I look at this, I've got this value that is immediately being passed in to this other method. It's not being used anywhere else. And so cases like this, I often take a step back and say, if I just look at this assign offer method by itself, it's using this data that was calculated immediately prior. And so would it be better off if I kind of like defactored it and inline this method as opposed to just immediately diving in and looking at a sign offer by itself. So let's do that. Let's go ahead and defactor this method, which is to say, reverse the refactoring we did before. And so to do that, I will use inline method. And what that will do is take the logic inside of there, and everywhere it finds this method, and I don't do this unless there's like 1 or 2 usages. If there's like 60, I have to be really, really careful, because like, well, maybe this logic should be in just one spot. But if there's only 1 or 2 usages, then it should be safe for me to defactor that method. All right. The only thing that's kind of funny here is that we had another offer being used here because it was being passed in. So what I'm going to do real quick is just inline that offer object and then fix the name of this to just be offer by itself. So refactoring tools will do things in a very safe way. It's not always completely logical. So sometimes you have to kind of rejigger it to be able to get it to the right spot. Okay, so at this point, this was the original method that we had extracted, and this is the extra value. So now let's actually extract all of this into an individual method. Assign offer. There we go. Okay, so at this point, I've got a single method called assign offer that has all the possible logic being passed, all the possible data being passed in to be able to act upon it. And then we also see that the method is static, so it's not calling out into any external dependencies. And so all the logic that is necessary to assign an offer to a member is now encapsulated in this one single method. So let's look and see what would be appropriate for us to move this method to be better suited and encapsulated inside of our domain. So again, what we'll do is look at these values one by one and see the usages inside of here and say, is it mainly dealing with this object? So if I look at offer type, I see 2 usages. The first is calculating the expiration dates. And then down here is assigning the type. I could actually further simplify this. This doesn't seem to be adding much value. It just calculates this value, then immediately assigns it over here. So let's just inline that variable, unless we need it for debugging purposes, and just say, well, all the logic needed to do that is just all right here. At this point, if I look at the usages of this, well, it's just being used for this building up of this offer object. So not that interesting, right? What about member? All right, so we have more usages, right? We've got the member here. We've got member here, what's doing some logic to assign add the offer to the collection of assigned offers. But it's also doing some calculation here. So this is some kind of extra business logic. So, well, I could look at value, but we can't push behavior down into an int. So our only recourse there would be to convert that into some kind of value object. But again, I don't see a lot of usages of value here. It's just that one single usage right there. So of offer type, member, and value. Oh, actually one more. Let's look at the offer object. So how much is this being used? Well, I'm constructing it. I'm adding it to these signed offers, but that's about it. So there's not a lot of behavior associated with the offer object here. It's just constructing it and then adding it to someone else. So of these 3 things, offer type, and member, it looks like member is the best candidate for us to be able to push this behavior down into. Now, I could try one of these other objects. So I could say, use this refactoring to say, make method non-static, and then just pick one of the others. Actually, let's try that, offer type. Okay, so now I have offer type that assign offer. But again, looking at here, like, this behavior is really dealing with something else and not really dealing with the offer type. So that doesn't look like a great candidate. So what we can do is just undo. And now it's back over here. I very often do this in my refactoring. I'll try one direction, see how it looks, see if it solves code smells or creates, doesn't create new ones altogether. And so that one didn't look like it made much sense. So we abandoned it. So let's go the other route. We'll go ahead and make this method non-static. And this time we'll pick the member object. Okay, so over here, instead of us calling the static method on this class, I'm now calling a method on the member object. And it converted, you notice the parameters. I'm going to go undo that. So member used to be a parameter to this method. when I made this method non-static, it converted that parameter. Oops, there we go. Oh, forgot to undo over here. Member, undo. I just convert it. All right, so if I extract, make that method non-static and choose the member parameter, then it also removed that parameter from the ones being passed in, and now it's now it's now the instance in which I call that method. And then inside of this method, every place I was using the member parameter being passed in, it's actually changing to use the instance values. So here, instead of being member assigned equals member, is member assigned equals this. Instead of assigned off member.assignedOffers.add, it's just calling this instance property right here. So now all of the logic to assign an offer to a member is encapsulated inside this one single method. So going back to my handler class, I have an external domain service that is calling the calculate method on. So if I need to test the offer value calculator that is a real implementation, I'd have an integration test to do so. The real meat of the logic to be able to assign an offer to a member is now in this single class, single method here. And this method is now encapsulating all that logic inside the member object. So if I want to understand what does it take to assign an offer to a member, it's now pushed down into the member domain object. So going a little bit further, I can also see that my member class has kind of a lot of anemia associated with it, and that allows basically anyone to do anything. Now, maybe I don't necessarily find usages of this, but I can do things like member.number of active offers equals int 32 at max value. Like, probably don't want to allow that. This is an important calculated value, so we probably don't want to allow anyone to do anything with it. So what we like to have happen, we can do things like member.assignedOffers.clear. Okay, so our object model allows that operation, and there's not necessarily anything in our object model that prevents that from happening. So in terms of having kind of a well-documented interface and well kind of clearly defined interface, this kind of fails that because it lets anyone do absolutely anything. So ideally, I wouldn't have like anyone being able to do anything to this. I would only allow mutations through a public API and nothing else. So the way I can tackle that is to get rid of a lot of these kind of private or public setters of things and public operations. So the first thing I might do is say, well, what does it take to actually create a member? What are the kind of minimum things it takes to be able to have a member object? So those minimum things for us are going to be, I have to have a first name, I have to have a last name, and I have to have an email. So let's create a constructor that is those things. So I'm going to generate a constructor that is the first name, last name, and email. I can check the parameters for null, I guess. And there we go, first name, last name, and email. And now I can actually just get rid of these setters, or I may have to make them private depending on your ORMs or how this is getting loaded to the database. You might have to make some small concessions here and there to be able to make those work properly. The same thing with number of active offers. Oh, wait, let's build first. Did I break anything? Let me run my unit test as well. Oh, I don't have any. I guess we're fine. I'll go away thing. So this build succeeded, so I guess we're good to go. All right, so what else do we have here? We'll tackle this collection later if we have time. Collections are a little bit different to be able to deal with, so let's just skip that for now. But the big one here is being able to fix this number of active offers. We don't want to allow anyone to do anything there. So if I were to get rid of that setter, let's see. Oh, that didn't like it. It said it's cannot be assigned to. It's read only. So let's go ahead and refactor this. Can I say somewhere I'm going to have to property with backing field. There we go. All right, so converting that to a property with a backing field just creates a private field that is the actual value that can be mutated. But what we're going to do is get rid of that setter altogether. And so down here, instead of me mutating the public property, I'm going to say number of assigned offers, number of active offers, plus, and we're not going to mutate that public field whatsoever. So now this property becomes what's known as an expression bodied property. So it only allows like gets, and it's going to be directly returning this internal field. But the mutation of that field is only possible through this class itself. If I were to build this, oh no, that broke someone. This is okay. Just means that there are other places in our application that are having to deal with this, are mutating this value as well. So what's this class? Oh, this is the expire offer handler. So this is the reverse of that before. So before I was assigning an offer, and this is going to be expiring an offer. All right, so let's see what we have here. We've got we got data access that's loading the member. We've got some logic here that is to find the offer in which I want to expire. I mutate the offer, and then I will decrement the number of active offers. So let's go ahead and extract a method for this and call it expire offer. Oh, it actually passed in the entire request object. So what I'm going to do is refactor this and introduce a parameter for that. And that will safely remove that request object. So I'm just going to pass in the request offer ID. I'm sorry, let's call it the offer ID directly, as opposed to that wonky request object. Okay, so looking at this, what's being used? I've got the member object being used a couple times, and then I've also got the offer object really just used once to change the expiration date. So between those two, it looks like it's mainly dealing with the member object. So I'm going to do the same refactoring we did before, which is to make this method non-static and move it to the member object. Now it's member.expire offer, passing the offer ID, and this expire offer, instead of dealing with the public property, it's going to be dealing with the private field. Now this is another instance method that I pushed down into my domain object, and I've now successfully encapsulated this calculated field into a read-only property that still can be persisted behind the scenes. Okay, I'm going to do one last thing, which is to look at this offer object as well, and say, we just did something with the member object to say, I require these pieces of information for it to be a member. Let's do the same exact thing for offer. If I look at offer, it's got member signed, the type, the date expiring, and the value. And it actually needs all four of those things to be a real object. So let's go ahead and create a constructor, which is all these different things: offer type, date expiring, and the value. All right. All right, so now I can now pass in all those values: the member signed, the offer type, the date expiring, which is this, and the value, which is value. So I don't have this anymore. Now the weird thing about this is I've got the offer type being passed in, as well as the expiration date. So if I go to offer, I can actually inline this parameter, which is to say, find all the usages of this parameter and replace the value internally with whatever that value that was being passed in. So when I inline it, it says source of the arguments to be inlined. It says this is the constructor, the existing constructor being called. If there were several of them, I could look here to see what is the commonality here. And if they're all the same, then I'm good to go. And so finally, it removed that as a parameter. So it said, here's the member signed, the type, and the value. And now the expiration date is now calculated from the type directly. And when it constructed the offer, it's just now these three parameters. All right, so what have we done so far? We have tightened up our domain objects in that they now only publicly expose the operations we intend to expose and nothing else. We still haven't encapsulated this collection, so if you want to go see the kind of the finished version, you can go download the code and see how we refactor that. But all the other things that you can mutate, I've protected now behind these public methods that only allow the operations that I intend to allow. But how do I know which operations I intend to allow? Well, I'm using refactoring techniques to do so. That is, the operations that I actually expose in my application, I'm using those as the means of refactoring into a domain model. And so that's why I really, really love domain-driven refactoring, is that I'm not kind of like building a domain model or domain objects, out of thin air or just making things up as I go. Instead, what I'm doing is using the behavior I actually find in my application and system and using refactoring techniques to build up the domain model that truly represents the operations I tend to allow and truly represents the behaviors that are represented in my system. Nothing more and nothing less. So if you want to see more and learn more about these sort of techniques, again, the two greatest books that I found out there are Refactoring and the Refactoring to Patterns book, as well as the Legacy Code book from Michael Feathers, as a way to provide you techniques for really, really untestable legacy code to be able to put those seams in like we did for that web service. So thank you all very much. I hope to be actually there next year, hopefully. But if you want to see the code behind this, go ahead and go to my GitHub at github.com/jbogard/presentations. The full before and after are going to be there as well. Otherwise, if you want to learn more about this topic, I blog about it a lot as well, so you can find me there. Otherwise, thank you all very much, and I hope you all have a great party next. And I'll be on to the Discord for Q&A, or whatever the Q&A is.
Yeah. Thanks, Jimmy, for that. I'm going to check to see if we have any questions here real quick. I did have one of my own as I wait for folks to react, Jimmy. One of the things with that domain-driven refactoring, how long would you think, sorry, maybe that's the wrong question. If I'm a mid-level software engineer, this is one thing I want to do to introduce to kind of improve the quality of my code for all the reasons you went over. How long would you budget for, if you're refactoring a class or an object, like how roughly is it a sprint before you start seeing these type of good results? Like what's the rough time frame when your experience has been before when you start practicing these patterns, you can kind of start seeing the return on your investment for doing this work?
Sure. So for me, this is kind of like a constant thing. It's not necessarily a separate activity or a task or a story. Those kinds of things I reserve for much wider impact refactorings. So like, let's say I have a class that's being used in 100 places and I want to break those dependencies. Well, that's something I need to put on the backlog because it takes more time. But something like this is something I in terms of seeing returns on, it's just kind of a constant feedback cycle to see, is this working, is it not, is it working, is it not? Which is why I also included those defactoring techniques, because very often I come into a new code base, I do a lot of refactoring, and then I undo it all.
Undo because you broke it, right? Or wow, it didn't work. Okay, so you just tend to do it as part of your normal day-to-day activities, basically. Exactly. Okay. I don't see any questions, Jimmy, but thanks so much. And as Jimmy pointed out, there is a party at 9:20 tonight, in person or virtual as well. I hope to see everybody there. And thanks so much, Jimmy. I'll see all the rest of you back early tomorrow morning or tonight.